Imagine waking up one morning to discover that your bank account is inaccessible, your favorite games won't load, your work collaboration tools are dead, your doorbell camera has gone dark, and millions of people around the world are experiencing the exact same nightmare simultaneously. This isn't a hypothetical doomsday scenario. This actually happened on October 20th, 2025, when a single technical failure at Amazon Web Services triggered a cascading collapse that exposed just how fragile our digital infrastructure really is. What's terrifying isn't just that it happened, it's that the root cause was something so seemingly mundane, a DNS resolution failure, that most people have never even heard of it. Yet this tiny technical glitch managed to bring down everything from Fortnite to banking systems, from Ring doorbells to national rail networks. And here's the part that should keep you awake at night. This will almost certainly happen again, possibly worse, and most companies aren't remotely prepared for it.
The cascading catastrophe nobody expected. On that October morning, something broke deep inside Amazon Web Services' US East 1 region in Northern Virginia. US East 1 isn't just another data center, it's effectively the beating heart of a massive portion of the internet. When AWS engineers finally identified the problem, they discovered it was a DNS resolution failure, affecting DynamoDB API endpoints. For non-technical folks, think of DNS as the internet's phone book. It translates human-readable website names into the numerical addresses computers actually use. When that phone book stops working, everything depending on it immediately goes dark. But the failure didn't stop there. This is where cloud infrastructure gets genuinely frightening, because everything is interconnected in ways most people don't understand. DynamoDB is a fundamental database service that countless other AWS services and customer applications rely on for storing and retrieving data. When DynamoDB's DNS resolution failed, it created a domino effect. Lambda functions couldn't execute, EC2 instances couldn't communicate, authentication systems failed, service discovery mechanisms broke down. What started as a single point of failure cascaded through interconnected systems like a digital plague, taking down service after service in rapid succession. The scale of disruption was staggering and revealed just how much of our digital lives depends on this single company's infrastructure. Gaming platforms went dark. Fortnite, Roblox, Clash of Clans, Clash Royale, Rocket League, and Pokemon Go all became unplayable simultaneously. Snapchat received over 5,000 user reports on Down Detector within minutes. Financial services collapsed. Coinbase, the world's largest Bitcoin custodian, went offline. Major UK banks, including Lloyds, Halifax, and Bank of Scotland, received thousands of outage reports as card payment processing systems failed. Enterprise productivity tools like Slack, Zoom, and Microsoft applications stopped working. Even physical security systems failed. Ring doorbell cameras went dark, leaving homes unmonitored. Life 360 location services disappeared, leaving parents unable to track their children. National rail transportation systems experienced disruptions, the economic devastation hidden in plain sight. The financial implications were catastrophic, though most people will never see the real numbers. Industry estimates indicate that 90% of enterprises face costs exceeding $300,000 per hour of downtime. With the outage lasting approximately 7 to 8 hours for full restoration, we're looking at potential costs of over $2 million per affected enterprise, and there were thousands of affected enterprises. AWS generated $107 billion in revenue in 2024, representing 17% of Amazon's total revenue. Service disruptions at this scale affect millions of businesses and hundreds of millions of consumers globally. The downstream economic effects, lost productivity, abandoned transactions, damaged customer relationships, emergency response costs, likely exceeded billions of dollars. But here's what makes this truly alarming. This wasn't even AWS's worst outage. In December 2021, US East 1 experienced what's considered the most severe AWS outage in history, lasting approximately 7 hours and caused by network device overloads and NAT gateway failures. In June 2023, elevated error rates and slow response times affected multiple core services, impacting high-profile customers, including the Boston Globe and New York's Metropolitan Transportation Authority. In September 2021, an 8-hour disruption triggered by Amazon EBS stuck I/O issues, impaired EC2 instances, and cascaded through Redshift, Elasticache, and RDS services. The terrifying pattern. nobody wants to acknowledge. Look at those dates: September 2021, December 2021, June 2023, October 2025. This isn't random bad luck. It's a recurring pattern revealing fundamental vulnerabilities in how cloud infrastructure operates, and all of these major failures share disturbing commonalities. They consistently originate from or heavily impact US East 1, AWS's most critical and densely populated region. They affect multiple services simultaneously due to shared underlying infrastructure. Recovery takes many hours even for partial restoration, with full resolution often extending much longer due to backlogs and cascading effects. They impact major enterprises and critical public services because of the concentration of important systems in this region. Why does US East 1 keep experiencing these catastrophic failures? Because it serves as a de facto global hub for AWS infrastructure. It hosts the largest number of AWS services and serves as the primary region for many global services. It acts as a central routing point for inter-regional traffic and global service coordination. It has the highest concentration of enterprise customers and critical applications. This creates a single point of failure for a massive portion of the internet, and that architectural decision is a ticking time bomb. The dependency chain that could break civilization. Let's talk about what actually broke and why it matters so profoundly. At the primary level, the DNS resolution failure directly impacted DynamoDB database services, Route 53 DNS services, IAM authentication and access control, and EC2 compute resources. But that's just the beginning. At the secondary level, Lambda functions triggered by DynamoDB events failed. CloudFront Content Delivery Network relied on regional origins that went dark. S3 storage cross-region replication stopped working. API gateways and service mesh communications broke down. At the tertiary level, and this is where it gets genuinely scary, third-party services built entirely on affected AWS services collapsed. Global services with US East 1 backend dependencies failed, regardless of where in the world they operated. Entire application ecosystems built on interconnected AWS services experienced cascading failures. Think about what this means practically. Your business might not directly use AWS, but if your payment processor does, your business stops making money. If your communication platform does, your employees can't coordinate. If your security monitoring system does, your facilities become vulnerable. You're not just dependent on your own infrastructure choices. You're dependent on the infrastructure choices of every service provider in your entire technology stack. The security nightmare hiding behind technical failures. While AWS insisted there was no evidence of cyber attack, the incident exposed security vulnerabilities that should terrify anyone concerned about cybersecurity. Previous AWS DNS vulnerabilities have exposed businesses to data hijacking risks. When DNS systems fail or get compromised, attackers can redirect traffic to malicious servers, intercept sensitive data, or impersonate legitimate services. IAM and STS service disruptions impacted security token validation, potentially creating authentication bypass opportunities. Database service interruptions raised serious concerns about transaction consistency and data integrity. When systems fail mid-transaction, data can become corrupted in ways that aren't immediately obvious. But the longer-term security implications are even more concerning. The heavy reliance on single cloud providers creates incredibly attractive targets for sophisticated nation-state actors. Imagine what an adversary with sufficient resources could accomplish by deliberately triggering failures similar to this accidental outage. The cascading failure patterns demonstrate exactly how cloud service dependencies create supply chain attack vectors. Compromise one service, and you can potentially cascade that compromise through everything depending on it. Financial services and healthcare organizations now face increased regulatory scrutiny regarding cloud concentration risks because regulators are finally realizing that putting everything in the cloud created systemic vulnerabilities that didn't exist when systems were more distributed. What companies should be doing, but mostly aren't. The brutal truth is that most organizations remain catastrophically unprepared for these kinds of failures. They've moved aggressively to cloud services to save money and increase agility, but they haven't invested proportionally in disaster recovery, business continuity, or multi-cloud strategies. Industry experts recommend several critical practices that most companies are ignoring. Conduct comprehensive cloud dependency audits to map every critical dependency on AWS services and identify single points of failure. Implement genuine multi-region strategies that distribute critical workloads across multiple AWS regions with automated failover, not just different availability zones in the same region, which often fail together. Develop cross-cloud capabilities so applications can operate across multiple cloud providers, not just AWS. Enhance monitoring with comprehensive observability platforms that can detect early warning signs of cascading failures. Implement chaos engineering practices that deliberately inject failures to test system resilience before real disasters strike. For long-term strategic resilience, organizations need even more fundamental changes. Prepare for emerging regulations regarding cloud concentration risks, because regulators are coming for this problem. Invest seriously in operational resilience testing capabilities beyond basic disaster recovery drills. Diversify vendor relationships to avoid catastrophic overdependence on single cloud providers. Develop internal expertise in multi-cloud architecture and sophisticated disaster recovery rather than relying entirely on cloud provider promises. The future that's already here. Here's the uncomfortable reality. This incident isn't an aberration or a one-time failure. It's a preview of our increasingly fragile digital infrastructure. As more critical systems move to the cloud, as more services become interconnected, as more of our economy and daily life depends on these platforms, the potential impact of failures grows exponentially. We've created a global digital infrastructure where single points of failure can cascade through interconnected systems in minutes, affecting hundreds of millions of people simultaneously.
The October 2025 AWS outage serves as a wake-up call that most people will ignore until the next, possibly worse, failure occurs. The interconnected nature of modern cloud infrastructure creates systemic risks that aren't being adequately managed by most organizations or sufficiently regulated by governments. As cloud computing continues dominating enterprise IT strategy, we need robust architectures, better regulatory frameworks, and dramatically improved disaster recovery capabilities to ensure the stability of our increasingly digital economy. The question isn't whether another major outage will happen, it's when, how bad it will be, and whether we'll finally start taking these vulnerabilities seriously before they cause truly catastrophic damage to our digital civilization.